So, hi everyone. I am glad to have the chance to give this talk to you today. So, as Dragan already mentioned, the title is API Design, Tips and Introduction into Building the APIs. Thinking about this topic, in this talk, it will not be a matter of talking about one correct approach, as there are many good ones. The goal is to talk about the ideas and thought process and how you can use those when designing and thinking about APIs. The talk will not cover the whole topic because this is a very, very big area to talk about. So I will focus on some of the selected areas that I found in my experience to be the most valuable when thinking about the API design. Examples shown in this talk are inspired by real life, some of which are simplified or adjusted to fit the format of this talk. First, let me introduce myself to you. As Dragan already mentioned, my name is Alen. I'm a deputy CTO and team lead of architecture team at Recoder. I've been building web apps and APIs for a very long time now. I've been building JSON API powered projects for the past 5 years. I'm doing talks, training, workshops, and educations as part of my daily work. Let me talk about a little bit about our company. So Recoder is a company based in Zagreb, Croatia, and we employ developers on-premise and remote, also from some neighboring countries. We are a medium-sized company with 65 employees, out of which 50 are developers and engineers. So we cover mobile, front-end, back-end, data science, UX, and UI. Our main project is Njuškalo. It's a classified platform which is #1 in... Oh, sorry. Do you see it now? Okay. Yeah, sorry. There was a miss in the shares. Okay. So we have our main project is Njuškalo. It's #1 platform in Croatia and also in Slovenia. And we are always open to hire new colleagues. So feel free to check out our website for more information. Onto the topic. So when we talk about the APIs, depending on your technical background, the API can mean several different things. So let's try to clear up this definition first. So in our definition, APIs is something that enables application to communicate with one another. This can be either server-to-server, client application, or some other service that you are building. So a well-designed API should reflect the goals of business, and it's designed to serve that purpose. The idea here we will talk about is web APIs, but the ideas and thoughts are also applicable to other areas as well. So when talking about the web APIs, we need to mention Restful Apis. So it's an architectural style for building distributed systems based on hypermedia, and it's not necessarily just implying HTTP. So web APIs is what we will talk about today. A couple of things to mention here. Web is usually a stateless request model using the HTTP, and the HTTP requests should be independent of each other and may occur in any order. This is something when thinking about how we will model our endpoints. So why we use APIs? So APIs are used to build for other web servers or client consumers, such as web browser, mobile application, outside services. One thing that we can also usually imply its communication is done using the HTTP protocol in some text format, most preferably JSON or XML. So before we dive into the APIs, we can also talk about the design word. Design word itself can have several meanings, and one definition that I found very useful is design is a set of decisions with the goal to define the look and functionality of the topic that you are designing. So it's a simple but valuable definition that can help us understand when we talk about the design. So what does this mean in a sense of API design? So API design is a process of developing interfaces for exposing our functionality or data to other applications. As such, good API design takes into consideration organization-specific strengths and limitations in terms of budgets, personnel skills, and technical infrastructure. So as said here, we need to think about also the technical approach, but also take into account the consumers and our business that we are trying to support here. One thing that we often come into across in our experience when talking about the API design is when people disagree on design, it's often they don't agree on the goals. And in my experience, this is one of the very important notes to have in your head. So because a lot of time the discussions is about the design, but we need to consider what is our goal. So for example, if there is a disagreement that the current design is not future-proof for the next 5 to 10 years, but our goal is to deliver some short-lived feature, then this discussion is not needed because it's not our goal. We are delivering something that has a shelf life, and very often in our area of work, our solutions have a shelf life because we are always thinking about how to upgrade them. So when talking about the design, a good design can be broken down into 3 main aspects. Those are purpose, usability, and constraints. So a purpose part, as we mentioned in the previous slides, is about fulfilling the business goals, about getting the right information to the right side. Usability and constraints, this, again, can be also covered depending on your technology stack and standards. You could already have this covered with some standard that you use. So, for example, in Tricoder, we use a Json Api standard, which I'll mention later in the talk, and also give some examples. And this has helped us a lot to really think about the important stuff and not to worry about conventions and similar. So to summarize, what is the API responsibilities? It's to provide the data and functionality to successfully complete a business goal. That business goal can be a sale, a conversion, a technology-related data exchange, anything that you are trying to cover. One also interesting thought to have is, I think everyone heard some variation of this, is good solutions have strong foundations. So when thinking about the API design, there is a way that I can actually try to visualize this. So looking at our solution, we built a solution to fulfill some requirements. And to meet those requirements, there can usually be 3 main pillars for building the solution. So one is a client pillar, one is an API pillar, and one is a backend pillar. Again, we are talking about the web concept here. So when each of these pillars are strong, we are happy and prosperous. And the success is when all of the 3 pillars are working towards a common goal instead of working towards the goal of one pillar. So looking at the example for in the relationship between the client and the API, there might be a case where our client needs the whole homepage for its app in one request. And this is something that usually in the API, we don't think about it like this. Or, for example, we have an article and the article has an image. So depending on the client, we can do it either sending a URL, or we can have some complex resources, additional logic behind it. Looking at the API and the backend relationship, this is where usually things get a bit more complex and it involves a lot of more work. So sometimes an API can copy backend implementation one-to-one. So we have the same data models, we have the same attributes. And this can be a good start. But often, because if we already know the backend implementation, we can be biased towards the design of our API. And this can sometimes limit our solution space. So if we approach the API design isolated from the backend, so not thinking about how the backend is implemented, we can sometimes come up with really great designs that work well. So for example, if in your backend system you have a document revision system, but on the API, you only need to serve the latest version of the document. There might actually be no need to show all of this revision system in your APIs. So when looking at these three pillars, if the pillars are too affected by each other, our construction can become fragile and unbalanced. We can become coupled to the dynamic of these solutions. So for example, if our client is doing UI redesign and we need to change, modify the APIs because of it, despite the data set being the same, this can be an indicator that we are too coupled to the client. Or if a backend is doing some refactoring or optimizations and it requires us to change our API, again, we are too coupled with the backend. Again, as this is the talk about the API, so I will focus now more about the API itself. When thinking about the APIs, one thing that we can also try to test is, okay, how will it serve multiple clients? Does it need to serve multiple clients? Will it be served through multiple backends? How will the filtering done? How will the format done? So there can be a lot of questions raised. What we try to do is simplify and focus on the content instead of form. So we should focus on what kind of data, what the data API provides, and not how. When we talk about how, we usually think about the formats, the structures, and communication. So this should not be our primary focus. So imagine a world where everyone knows what your APIs work, how your APIs work, and you just need to tell them what kind of data you are serving from it. So as I mentioned before, in Tricoder we use Json Api to help us with this. What the Json API provides is enables us to stop worrying about the structure and covers a lot of frequent questions that we might find. Json API removes for us the need to invent things that we don't need to reinvent. The JSON API itself is a resource-oriented API. They do have a really well-written specification, so I would suggest, if you're interested, to take a look at it, and I'll go over a quick overview of basic features of the JSON API. So looking at it, so this is a basic structure of a resource. It is comprised of the type, so usually some kind of type describing the resource, the ID of the resource, and some attributes. Like a real-world example, let's see an article. So we would have an article with an ID 1 and a title and the body of the article. And so when we think about, okay, so I have an article, I might need to see an author of the article. So this is done using the relationships. So we can define a relationship and say, okay, a relationship to this article is an author with a type of people. So it gets pretty easy. Again, thinking about, okay, I know the ID of the user. It would be great if I have this user included in my resource. So again, I can just simply have it included in the main response. So again, this is the response from the main endpoint. If we need a relationship of a relationship, yes, the related resources are also resources, so we can have a relationship. And again, using included, we can include the relationship of that. We can include the resource of that relationship as well, so we can get the article, the author, and the thumbnail used to show this author. It looks beautiful. So to summarize what the JSON API provides us that we don't need to think about, so it provides us with client responsibilities, it provides us a definition of server responsibilities, it defines a document structure, it provides a fetching of resources and relationships, and it provides us sparse field set, so we can just have a selected set of data instead of the complete resources. In addition, it also provides us definition how sorting can be done, pagination, filtering. It provides a full CRUD operation, so it describes how we can create resources, update them, update relationships, delete the resources, and it also provides a standardized errors. So again, it's a nicely written specification. If you're not familiar with it, feel free to check it out. So now that we covered some of the definition and some of the thought process, we can dive into the example because there's a lot of good things to go over. So first use case we have here is a user registration. I think that everyone has once in their life of development met with some kind of user registration. So let's look at our requirement. So we have a requirement that says that we have a mobile app, mobile and web apps. So we have two clients that have two-step registration. In step one, the user enters his username, email, and password. And in the step two, it enters additional personal information like name, surname, or phone number. So when we think about the API design, how would we solve this? Well, there's actually a trick about it. We don't. So we ask the clients, hey, this is not our problem. So from the API design perspective, we enabled it. What this means. So we separate the work. So client is responsible for covering the steps, and the API needs to provide a way to validate and complete the registration process. So we would serve an endpoint to validate or verify the user entered data, and we would serve an endpoint for process of registration itself. If we look at the resource, how would our resource look like? So we would have a resource of the type user. Again, this is just the naming. We can call it user. We can call it a guest, a person, a buyer, depending on your business language. And we would have some attributes, for example, username, password, first name, and last name. So if you've ever done a registration, there is another example we can mention here. Usually when you ask for the password, it's a good practice to have a repeated password, just in case the user misses or types it wrong. So again, this is something that we shouldn't do on the API level. It should be done by the client itself. So the client can verify that two passwords are the same and just send us the password. Again, if we want to think about it differently, we can probably define the registration as a process of sending a registration request to create the user, and then we can model our resource as such. So we could have a resource that is type registration request with the same attributes. So we would have username, password, first name, last name. And then when we think about it, okay, so I send a request for registration, and when I get a success response, we can have the created user as a relationship. So we can have additional relationship, which is user of type user. So for any fans of the RPCs, this is one option how you can do it when you use JSON API. What endpoints should we provide? So we need an endpoint for creating of the user, so for a resource, and we provide additional endpoint for validation. Validation and can have a response okay if the validation is correct, or a conflict or some kind of custom error. And if we look at the other example for registration, it could be a similar. So we have a registration endpoint and registration validate endpoint. Okay, next use case is classified. To help with anyone who's not familiar with the term, classified is a business for selling of online, like, for example, an eBay. In our case, we work for a Croatian platform called Newscall. The items that you're selling are usually called a posting or a listing, sometimes ad. And this use case will be an example of evolution of the design as we get more knowledge, additional requirements, and to get more familiar with the topic that we are covering. So first requirement is we need to serve the list of posted listings. Sounds simple enough. So we would create a resource called listing, and our listing would have a basic attributes of title, description, price, and when it expires. And it's a simple resource. We can have a list of them and just serve all the listings in the database. But then we get additional requirement that says, hey, can you please include seller information like his name and his contact information. So again, a simple approach would be we just modify the existing listing with the title, description, price, and expires on, and we add a seller name and seller contact phone. It's a simple addition. But this is where the design thought process starts to think. So the seller data can also be separated into additional resources, and it can be reused on other endpoints. So we could do it as additional resource. So we would have, again, our listing with existing attributes, and we would have a relationship to a called seller to a special type of resource. And let's look at some of the examples. So first example would be we can have a resource type seller, and then we can have an attribute called display name and contact phone. It's a pretty simple one. We can be a bit more descriptive. So again, we could have a seller, but we could also signify that the seller is actually a user. So we would have a relationship to some existing user. And in this case, our consumers can get even more data about it. But looking at this example, we can also think about the third example, is that relationship to the seller is a user. So we can just have a resource user, and we can have his username and phone directly attached. With this example, then we get a new requirement which says, hey, mobile application needs to mark ads that are owned by currently logged in user and expand on additional data. So thinking about this request, how can we solve it? So if you remember the previous slide, it sounds like a UI thing, right? Well, correct. We could enable this. So we provide the mobile application with the example to get the current logged in user. And then the mobile app can have a simple logic as, hey, if the classified seller ID is the same as the logged in user, this is the logged in user. So no additional data is needed for the API. And this is one example where we could become coupled to the UI. But again, if we think about the design, if we think about the requirements, define them correctly, define the goal, we can already see that this solution exists in our system. Let's look at another use case. So there is a requirement that says, okay, I as a user need to see my items. So we need to enable a seller to see all of the listings that he is the author of. So there are a couple of ways we can do this. So one way, looking at JSON API perspective, we could filter the classifieds list and say, okay, filter classified list where seller is X, and the X can be an ID of the logged in user. Again, this is all up to the clients to figure out the logged in user. Another example can be that we can add a special identifier called me. And in that case, depending on the context of the request, we can see, okay, who is the user authenticated with this request. Oh, we can then filter it for the client. This is a bit more friendly to the clients, but again, it might be a bit more coupled to the client and to the backend pillars. Another way, we can also create a special endpoint like classified me, or we can also create in the users on the user relation to the classified, so that the user can filter all of the classifieds that are related to his user. So again, to notify here that me keyword is a special in this case, and this is again very, very specific to the implementation and a bit more coupled to the backend. So this is something to take into with caution. Another use case, let's look at the messaging. So we have a simple functionality where a couple of users, for this example, a seller and buyer, can have a conversation on the item or listing. So looking at the resource, we could have a resource type conversation, and we have participants. So we can have the attributes of when the conversation is created, and then we can have a relationship to a classified. So this is the item that we are discussing about, the buyer and the seller. So the two users that are currently participants of this conversation. So looking at this, conversation can have also additional attributes, but we could already maybe simplify this. So we can have conversation that has a seller and a buyer, and both of them are specified specific resource types. So we can seller with the type seller, buyer with the type buyer, but also we can reuse them, because looking at both of these user types, they can be type of user. So we reduce the number of special resources that we have. Another example, another design choice that we can do here, looking at the conversation example, is that we can have a classified. So we have an item that they're discussing, and we also have a seller. But we already know the seller from the classified. So we can say that seller is redundant, because we can just say, hey, give me the seller of the classified. So again, design choice that we can simplify the endpoint by complicating the job for the client. It's a design choice. In this case, it's really hard to say which one of the two is better. Now that we have a conversation, we also need to have some conversation messages. Again, here is we can have a resource type message, and then we can have a design choice. Do we group the messages into conversations, or we connect them directly to the participants? So for example, we would have a message that has a content, it has a sent on, and it has is read. It's always read by the recipient. And then we can have a relationship that says, okay, it's part of the conversation X, it has a sender, and it has a recipient. Looking at this, maybe we can find some redundancies, because in the conversation, we only need the sender, and the recipient is the other party in the conversation, so we can probably move this. And also, when we think about sender and the recipient types, we can look at some options. So we have a sender, who can be a resource type sender, and we can have a recipient who is a resource type recipient. Thinking about the previous example, they are both message participants. So maybe we can have a reused resource type that has, okay, this is a conversation participants, and we can reuse them. Another thing, so we can also remove the recipient, because we already know that recipients are all of the participants in the conversation. So again, we can simplify our message resource and look at the conversation resource for more information. Talking about the resource types, so too many resource types can become a problem. It can be a maintenance problem, it can be a design problem, because you start to maybe lose the track of which resources are intended for what. So for example, we can have a user, we can have a buyer, we can have a seller, then we can have the sender, recipient, customer, etc. So if you look at all of these resources, they can all be basically come down to a simple user or a customer or some other solution that works for you. So again, take into account, it's nice to have a really specific resources, but when you build your APIs, it can become overwhelming and it can become a maintenance nightmare. Another use case that we can look about is search. So we have a simple request. We have one search endpoint for several resource types. So we can, so let's look at the one solution, how we can build our search functionality. So we have a resource type that is search result, and then it can have an attribute of title and some excerpt. So we can show the matching keywords, and the relationships is where it gets interesting. So let's say we have three main resource types that can be in our search results. So we can have a classified, we can have article, and we have category. As the definition of Json API says that you should only serve one resource type with endpoint. So we need to have a search result. And then using a relationship, we can say, okay, this is a classified, this is an article, and this is a category. And then within the included, we can have the complete document. Another alternative for this can also be we can reuse a relationship. So we can have an attribute with a title and excerpt. And then we can have just one relationship, which is called the result. and depending on the type of the related resource, we could know that it's a classified, it's an article, or it's a category. So this is another example of how we can do this. There are many more examples that I could be showing, but given that we cannot be here all day, so yeah, I've selected a few of more interesting ones, and I hope you had a great time. Some takeaways that I would maybe hope to give you today. Content and data. We are building APIs to provide some data, some content. Naming is a big part of our design, as well as thinking about how we will name things. And design decisions are something that we do every day. So it's not a matter of the best design choice. It's a matter of, is this design choice good for us? Sometimes there are several design choices that can be made that have a similar list of pros and cons. It can be difficult, but then it's just a matter of, okay, pick one and continue on. When I talk about the API design and APIs in general, so this is not the all that it's covering this this area. There are some additional topics that could be covered, like how can we do documentation on the API design, how can we do testing and validation of our APIs, versioning, security. So what kind of security are there? Not just authorization and authentication, but also rate limits, bot protection, topics like that. There is also caching and backend speed optimizations. There is some recipes that we can use to improve our APIs like that. And also a lot of implementation details on how can we implement our APIs. So that is it for me. And we can go over some of the questions and the Q&A. You're muted, Dragan.
Okay.
Yeah. Hi.
So let's see if we have any questions so far.
Yeah.
Yeah.
Between.
Okay.
Okay. So there's a question: where do you draw the line between? Requirement engineering and API design. Is the API design? The API design is, I would say, a result of the requirements. Just like you do UX design, sometimes the wireframes are part of the requirements, but it's usually the requirements define what we need to achieve, and the API design is part of the technical solution. How will we achieve our goal? So if there is some, let's put it like this, one thing that can affect the requirements, if there is some design choice that can help us save money, time, and bring better results, then we can go back to the requirements and ask for change. But usually we have requirements and then we get, then we go to the design stage. Does this answer your question? Great.
Okay. I have another question.
Are we using Swagger to build our API docs? No, right now we are using a Postman to document our APIs, and we also use it to test. So right now this is the tool we are using. We have used Swagger to build some APIs, more specifically the Open API specification.
Okay, another one. Is there any type of lag that can help better visualizing the API design?
Yes. I'm thinking about how to answer this because there are a couple of ways I can answer this. So I don't know if there is any done tool, like an out-of-the-box tool, but one thing that we have been doing is building a map. And this is one thing that JSON API is really good, because all the resources can be, so basically a JSON API enables us to build a relationship or a relationship diagram of the whole API. So yeah, we have some tools that we developed to help us like build a UML diagram of all of our resources, relationships, attributes, etc. Yeah.
Okay, a lot of questions coming up.
Preferred deployment technology. This is a little bit out of topic, but yeah, I don't know, from Ansible to thinking about it right now, this out of the box. Yeah, we've used Ansible for some stuff. We used custom solutions for some stuff. We used Symfony provided tools. So yeah, anything that works for you. This is really specific to the technology stack, to the solution, to the infrastructure. So there is a lot of factors, I would say, to answer this question a bit more fairly. Yeah.
Any recommendations on how to return errors to the client, and what's the importance of using HTTP status codes in this regard?
Short answer, Json Api. This is again a great thing about the standards that we use. Json Api standard, which already helps us to describe how we should return errors. What are some of the status codes that are already part of the standards, but there are some that we use customly. So yeah, I would say use it semantically. If nobody hates me for saying it like that. Yeah, so Json Api is really good for that. It helps us a lot with these kind of questions. Yeah.
Okay.
Do you include testing in your process? I would say testing is part of the development process. But again, depending on which tools you use for the design. So for example, we use Postman for the API design itself. So when we are done with the design, we already have a complete Postman collections, and we can use it for testing. We can also automate it. So yeah, so we can use it. We can use it in that way. Yeah. Oh, I love this one. Yeah, I actually have on one slide prepared for this. Yeah, this was a common question. So the GraphQL is one of the technologies that we have used, and how to say it? We've used with it. They are pretty simple. So despite they're being described as data and this is a resource, the JSON API for us has clear conventions, which helps us speed up the development process. It has the right amount of implicit versus explicit. So GraphQL is a great tool if you need a bit more, not to say freedom, but yeah, if you like to design your own stuff. But if you really want to use some standard, JSON API works just fine. And if you compare the two, they provide pretty much the same functionality. So yeah, I wouldn't say that either of them is better. It's a personal taste, maybe. Yeah.
Okay. Regarding content of data, how would you rate having values in field that reflect enums instead of easily readable values? Example, blah, blah, blah.
Yeah. So a philosophical answer here would be if you're using a strings or integers, they are both enums. So we have a key that means something. So if you use to or if you use call, they are both kind of enums. But yeah, so this is an example where it's really good to separate the two pillars. So from the backend perspective, you're using number constants. From the API perspective, you want something that is easily used by the client. So I would probably, most of the time, I would prefer string, so call, something that when you look at the API as a human or as a some kind of program, you can then translate them into your own values. So if you use value two is very backend specific usually, and if you use call, it describes the action. So it doesn't matter what constant is behind it. So yeah, this is kind of the answer. This is a really good example where you think about separating the backend from the API. API is built for the consumer. Yeah.
Another one.
How much an API script could be complex? How JSON Api was in the performance issue? Yeah, this is a good question. In short, so the performance of the JSON API really depends on your implementation, because you can implement it to be really fast, and we have had some good cases where our implementation was really fast. But if sometimes we weren't maybe so oriented on performances, and yeah, you can really quickly degrade the performance. But it depends on your technological stack. You can improve it. But from our example, JSON API can be really performant. So there isn't a lot of problems with getting it to be performant. Yeah. Have you heard of Net.js framework? I cannot say I've heard it. It sounds like it's a JS framework, so maybe I should ask if somebody from my front-end colleagues is here to answer. PHP TypeScript. I mean, in the company, so Tricoder is PHP based for the backend solutions. We use Symfony, but we also have building a Node.js based backend solution. So we are using Symfony and some Node.js solutions in the company. What is the preferred way to implement pagination API? The JSON API way. Again, this is a good question, but we follow the JSON API specification, and they just defined there's basically two main strategies how you can paginate. One is offset limit, and the other one is a page size. So the JSON API offers two ways you can paginate depending on the preferences of the client. Yeah. Can you talk about best practices of API version? In my personal opinion, okay. I would maybe call it good practices. Best practices is this is kind of where it gets discussion. Oh, something is better than the other. Yeah, I could talk about it. I actually have in the longer version of this talk, I actually mentioned a couple of things about the versioning. So you could either version by headers, you can either version by URL, you can version by resource. Yeah. So I would say not in the time that I have right now, because it's a really a wide topic, and I don't know, there's a lot of options you can go with it.
Okay, thank you, Alen. A lot of questions today. I think we come to the end.
So if you're still, just maybe to mention, if you have any other questions, feel free to contact me, contact our company, or send me a message on.
Yes, and the recording of this talk will be available in a couple of days online. So
Great.
You can come back to WeAreDevelopers website and find the recording. Back to Stefan, if he's still with us. If not, thanks. Okay, he's here.
I'm still alive.
There's another question. If we can
any advice on implementing rules and permissions on API design?
So this is kind of what I mentioned with constraints in the three main principles. So if you use standards, you already have some rules in the place. Another big thing is naming. So if you have a ambiguous language, some kind of dictionary that you agreed with your business, this is again something that can help. And yeah, that would be probably the two most important ones. Because if you use standards, if you use business terminology, you already have the HTTP standards. So there are a lot of rules that can help us so that we don't need to reinvent something that is already there. Yeah.
Okay.
Okay.
Thank you, Stefan.
So let's get out of here and be with a video again. Thank you, Alen. Thank you, Dragan. It was very interesting.